A uniform rod of mass 1.0 kilograms and length 3.0 meters is free to rotate about one end. If the rod is released from rest at an angle of 30 degrees with respect to the horizontal, what is A. The speed of the center of the rod as it passes the horizontal position. B. The speed of the tip of the rod as it passes the horizontal position.
We can write energy conservation for this rod for the beginning as mechanical energy initial, mechanical energy final. Height of the center of mass compared to the tip of the rod is h/2. Therefore, mechanical energy is only potential energy, mgh/2. When rod passes the horizontal position, in that case the center of mass is h/2 much lower. Therefore, that's the reference level, so we cannot write potential energy for that. If you do, it's going to be m times g times 0. And while it is passing the horizontal position, we have only rotational kinetic energy, 1/2 I omega square. Moment of inertia for this type of rotation is given as 1/3 ml square. With that, we rewrite mgh/2 equal 1/3 m length L square and omega square. After some simplification, it's 2 and mass m 3 gh 3 times gh equal L square omega square. So omega is 3 gh over L square. That's omega. Part A says, what is the speed of the center of the rod as it passes the horizontal position? So the rod is here, and that's the length while it is passing the horizontal position. So there is center and the tip. So V equal omega r square root of 3 gh over L multiplied by r. In this case, for part A, r is half the length, L/2 times L/2. It simplifies to 1/2 square root of 3 gh. For part B, the speed of the tip of the rod as it passes the horizontal position. So that means I need to take the same equation from linear speed to angular speed. And we found that angular speed is square root of 3 gh over L square. V for tip square root of 3 gh over L, and R term is the full length. You just need to multiply by L, and after the simplification, V tip is nothing but square root of 3 times g times the height h. If you are interested in numerical answers, 3 times g times the height in this case h, that's the angle theta, and the length L. From here we can write sine of the angle, sine theta is h over L. H means L times sine theta, L times sine theta over L square. That means square root of 3 times g times sine theta over length L. SQRT 3 times 9.8 times sine of 30. The length was, angle is 30, length is 3 meters. This is 3 meters. So that gives you 2.21. 2.21 radian over second. That's omega. For VC, it was 1/2 3 times GH 0.5 times square root of 3 times 9.8 times the height. Height we found L times sine theta. Length is 3 meters. Sine of 30. 3.32 meter per second. We could find this directly using V equal omega R, because we already know omega R, or VC equal omega R, omega times length, half length L. Omega we found 2.21 radian over second, and the length was 3 meters. 3.0 meter over 2. 2.21 times 1.5, half of 3. So it gives you 3.315. That's the rounding. The same answer. Equal the same answer. This was part A. For part B, V tip equal square root of 3GH. Because we already found half of 3GH as 3.32, that means twice of 3.32 is 6.64 meter per second. Alternatively, or we could use the same approach using the equation that we did above. Linear speed and angular speed, V omega R and omega times, in this case not L over 2 but it's L. Omega was 2.21 radian per second, multiplied by, now not the half of the length 3 meters but full length 3.0 meters.